All right. So, hello and welcome everyone. Welcome all of you to this particular channel of Pradhan Academy. Okay. So today we are back again with another important session. So as you all know that we have been started discussing the JEE Mains previous year questions from the topics of different chapters of maths. And today especially, so we had started with the discussing the concepts of calculus. Okay. So if you go to the channel and in the live sessions, you will find the session that has been taken so far, right? So we started with functions, we moved to the limits, and then today is our time to discuss on continuity and differentiability. So if you have watched the last session, what we have taken on limits, you must know that we have discussed the concepts regarding the continuity and differentiability in the last session itself. Okay, but I will also take this topic again today also to show you that what all things you need to recall before you start to solve the actual problems. Now today I have done an interesting thing is that I have taken some questions from the previous year JEE advanced questions. Okay, so today it is going to be an interesting session. Okay, so I would request all of you to please watch the session till the end and try to understand these concepts, and also once you understand the question, try to solve it by yourself as well. Okay, so I hope you have done quite a good revision of this particular topics of limits, continuity and differentiability. Okay, so once you're done with that particular thing, we can basically start to discuss this today's session on limits, continuity, and so today especially we are going to talk about the questions from continuity and differentiability. Is it clear? So if you're new to this particular channel, I would request all of you to please hit the subscribe button and don't forget to hit the like button. And if you like this particular content and you want to get the upcoming notifications, so don't forget to hit the bell icon, because that will give you all the upcoming notifications of the content that we are going to discuss on this particular channel. Now the contents that I'm discussing are going to be very important and very useful for your upcoming JEE Mains preparation. So keeping those things in mind, we are basically going to discuss the today's topic of continuity and differentiability. Now again, I like to tell this thing again and again in every session is that whenever you are studying any topic, you have to basically start from the NCERT. Once you are done with the NCERT, then move on to discuss the questions from the NCERT exemplar. So once you are done with these two things, then you are basically ready to jump onto the JEE Mains previous year question. So that is the basic guideline that I would like to give all of my students basically whenever you are revising or practicing for your JEE Mains, right? Because if you look at your JEE Mains paper, more or less the questions are almost kind of a repeated or repetitions are there, right? So once you understand the pattern, once you understand the trend behind the question, you are able to solve most of the question for simple way, right? So today also we are going to do that particular thing. So our topic is going to be continuity and differentiability, and we are basically going to discuss the previous year question. Okay, and if you're new to this particular channel, you can also check out the contents that I have taken so far, right? So if you know, if you have been following me from quite a long time, then you know that I have already covered algebra, I have already covered coordinate geometry, and I'm on the journey for covering the calculus. And once this is covered, we will start with vectors and 3D, and then that's how we are going to end the particular syllabus for maths, right? So we will have some more few topics regarding the parts, like the important parts like heights and the trigonometry. Okay, so trigonometry I'm going to take it separately in a particular sessions. Okay, so we will also have some trigonometric sessions where we are discussing about the trigonometric equations, trigonometric inequalities, trigonometry, the basic trigonometric identities. We will also discuss about the solution of triangles. We'll discuss about the heights and distance. Okay, and we also going to discuss about the inverse trigonometric functions. Okay, so that will completely cover your entire syllabus for the maths portion. So that is, we are definitely going to cover it before till your April. So that's what my target is. Okay, so let's see how far we go with that particular continuation. So with this, let's start our today's session. So today our goal is to discuss the concept of continuity and differentiability, previous year questions of JEE Mains, MCQ and numerical types, and also previous year questions of JEE Advanced, and we will try to see a paper pattern. So if you look at the last session, I have been discussed about the weightage of the chapters or the topics from LCD. So you can at least expect 3 to 4 questions from this particular part of limits, continuity and differentiability in a paper. Okay, so the 3 to 4 question that basically makes it a very high weightage particular topic. Okay, so therefore you have to prepare this particular topic quite nicely, and once you get the basics, this topic is going to be very, very simple. Okay, so with this particular word, let's get started on solving the very first question of today's class. So this is your first problem, right? Now I would request all of you to please have a look. Okay, now this is a question which I have taken from the JEE Advanced 2024 paper. Okay, so if you just look at your JEE Advanced question paper, you'll find this question from your JEE Advanced 2024 paper. Okay, so this was a question I have taken up from the JEE Advanced paper. All right, so let us try to understand how we go to proceed with this question. So the question is saying that we have to find out that for k belonging to real number, it is said that the limit x tending to 0 positive, or all the positive values of zeros, okay, or it is 0 positive means the right hand side of 0, or right hand limit at x equal to 0. So we have to basically find the right hand limit of the function sine of sine kx plus cos x plus x whole to the power 2 by x, and it is given as it is equal to e to the power 6. Now if you look at this particular problem, you might get a feeling that it is basically of the form of 1 to the power infinity, 1 to the power infinity, right? So this is very obvious to understand. This is the basically of the form of 1 to the power infinity, right? So how do we solve for the questions of 1 to the power infinity form? That is very simple. So let me write it the formula over here. So whenever you have to solve for limits of 1 to the power infinity form, what you are going to do is that, let us say that limit x tending towards some particular value a, f of x is equals to 0, and the limit tending towards that particular a, your g of x is also tending towards 0. And then if you have to find the limit, for x tending to a, 1 plus f of x whole to the power 1 upon g of x is basically of the form of 1 to the power infinity, and the solution is basically e to the power of limit x tending to that particular number a into f of x into 1 upon g of x. Okay, that is in the exponent. Okay, so if you just calculate this, you're going to get the solution. So over here from this particular part, it is going to be equal to limit 0 plus e to the power limit 0 positive, and then we are going to have it as sine of, so over here we are going to have it as sine of sine kx plus cos x plus of 2 minus of 1 whole multiplied with 2 by x, whole multiplied with 2 by x. Okay, and it is mentioned it is equals to e to the power 6. So from here, if you just compare this particular limiting value is just equal to 6, so therefore I am going to calculate the limit extending towards 0 positive 2 by x, and the numerator part is sine of sine kx plus cos x minus of 1 plus of x, right? So that's how we have to calculate the limit. Now what I'm going to do over here is that I'm going to simply use the form that I know that whenever limit x tending towards 0, I have the form sine x by x, it is equals to 1, and similarly the trigonometric limit when x tending towards 0, 1 minus cos x divided by x square, it is equal to minus of 1 upon 2. So I'm just going to use these two things, and therefore I'll get limit x tending to 0 positive, or right hand limit 0. Then I will try to make it of sine kx divided by sine kx. Then if I'm dividing by sine kx, I have to multiply by sine kx, right? And then divided by kx. And if I'm dividing by kx, I have to again multiply with k, because x is already there, right? Now, and then plus of 1 minus, and this is I'm going to make it of 1 minus cos x divided by x square, 1 minus cos x divided by x square, right? And this is equals to 3, because I'm cancelling out this particular 2 with this 6, right? So that is going to be 3 over here. And then if we try to solve it further, so what I'm basically doing, I am dividing by another x over here, so I have to multiply by x also. Okay, so this is what I am basically trying to do. And now this is going to be equal to 1, this is also going to be equal to 1. So from here, the limiting value I will get it as k plus 1 minus of, this is going to be equal to 0. So I am going to have it as k plus 1 is equal to 3, and from this I am going to have the value of k as equals to 2. So that is what my answer for this particular problem is. So just simple manipulation in this particular problem. So once you know how to solve questions of 1 to the power infinity form, this question is very simple. And I am repeating this question because the 1 to the power infinity form is the most important and favorite form for the JEE questions. Okay, so if you look at the JEE mains questions, the mostly 1 to the power infinity form is repeated many times in your JEE mains examination. So that's why focus on the 1 to the power infinity form clearly. Okay, so once this is clear, your option is going to be equal to 2, which is option number B, which is going to be the correct answer for this particular problem. Now tell me, is this clear or not? Okay, now tell me, is this clear? Is this part clear to all of you? Is this particular part clear to all of you? Please let me know if this particular part is clear or not. Okay, so I hope this is clear to all of you. So this is a JEE advanced question. Okay, so you can see how simple the problem is. Once you are able to solve the problem, once you know the trigonometric formulas or the limit, and you just have to manipulate the questions in such a way that you are able to evaluate the answer in an easy way, and that's how you get to the answer of this particular problem. And from here, if you solve for the result, you're going to get it k is equal to 2. That is the question that you need to solve for, right? That you have to find out the value of k. So you got the value of k as equals to 2. Is this clear to all of you? If you have any questions, don't hesitate to ask that question in the live chat. Okay, and if you're someone who is watching the session after the live class is over, you can always put your questions in the comment section. Okay, I'll be very helpful, and it will be very wonderful if I would be able to answer your questions. Okay, any query, anything you have, any doubts regarding the topics, regarding the question, regarding the way of solving the question, you can definitely put that up. Okay, and I will be I am very happy to understand a new method from you. Okay, if you are able to solve the question in a different approach or a different method, I'll be very happy to take up that particular method from you. Okay, so with this thing, I leave to you, so please don't hesitate to ask the question. Okay, so let's start discussing the next problem. So again, I have taken one more question from the JEE advanced paper. Okay, so if you look at your JEE advanced questions, you will find this particular problem also that has been asked in JEE advanced 2022 paper that was conducted by IIT Bombay. Okay, so 2022 paper, and if you look at this problem, it is said that it is again a problem of limit where we have a given sequence, right? So if we look at this particular sequence, and we have to basically try to get a sum of this particular sequence when your n is tending towards infinity, or you have very large value of n, right? So let us try to understand. This question is saying that f of n is equals to n plus 16 plus 5n minus 3n square divided by 4n plus 3n square plus 32 plus n 32 plus n minus 3n square divided by 8n plus 3n square. Okay, and so on. So I am not writing all the terms, but if you try to understand, now we have to basically try to figure out, to find out. Now this question is really interesting, because you have to basically do a lot of manipulation in order to get to the value of limit n tending towards infinity for this functional form, that is f of n, right? So how am I going to do this question? Now this question is basically called as a limit as a sum, or limit as a infinite sum. Okay, limit as a infinite sum, or definite integral as a sum of limits. Okay, so we have to basically try to convert this particular problem into a problem of definite integral. Okay, because you will try to understand when your summation is going towards infinity and you are having this particular form, so it is going to be the form of the definite integral. Okay, it is going to approach a definite integral form, and that is what we are going to do, and try to understand how we are going to change this form, right? So if you just recall quickly that whenever I have form like r going from 1 to n, and if you have f of r by n into 1 upon n, and here the limit where n tending toward infinity, then this is nothing but it is basically converted of the form of like integral a to b f of x into dx. Okay, and this a and b are simply calculated by putting this r value, r by n, and tending this infinity, the limit. Okay, so that I will tell you how to calculate this a and b. So this is what the form of definite integral that you are going to consider and try to change it, right? So let us try to see how do we do that manipulation over here. So if you just look at this problem, so if you just look at this problem, so if you just look at the first term, it is n. Now let us try to understand what I'm going to do over here is that now I'm going to split this n as summation of 1 plus 1 plus 1 and so on up to n times 1, right? So I'm going to split this particular n as sum of 1 n's. Okay, so if I have to split this up, and the why I'm doing this, you will get it by that very simple is that I'm going to take this up 16 plus 5n plus minus of 3n square divided by 4n plus 3n square plus of 1, and we'll consider this one term, and then the next term, that is 32 plus n minus of 3n square divided by 8n plus 3n square plus of 1, and so on. We will go on doing it, right? Now interestingly, why I did this plus of 1 over here, you will get this understanding that when I did this plus of 1, this 3n square and this minus 3n square get cancelled out. Again over here also this 3n square and this minus 3n square get cancelled out, and therefore you will have that particular f of n value as simply equal to 9n plus 16 whole divided by 4n plus 3n square. Similarly, this part is also going to be equal to 9n plus 32 divided by 8n plus 3n square, and so on up to the last term, which is going to be equal to plus 25n divided by 7n square, right? So that's what the terms are looking like. Now if I try to write it in terms of a summation or a shorthand notation where r goes from 1 to n, you can write this particular expression as 6n plus 16 times of r divided by 4n plus 3n square. And then if we have this expression, I will try to write this as a form of f of r by n. So let us try to express this in r by n. So what I can do, I can take 16 n common, so that is going to be 9 plus 16 times of r by n divided by, this is going to be 4 plus, so this is going to be equal to, sorry, there is a mistake, it should be 1 r over here, right? There should be 1 r over here, so let us add 1 r over here because that is also increasing, right? So we'll have 1 more r over here and this, like, so we can write this part as r by n plus 3 by 3, right? Like that. We are dividing this by n square, and then we are taking that simple n in the up also, right? So dividing by n square over here. I hope this is clear, right? So we are basically dividing by n square, and this is basically dividing by n, and therefore we will have 1 by n left out, and then summation for r goes from 1 to n, right? Now we have to find the limit. Now we have to find the limit for n tending to infinity. Then this form 1 by n summation of 9 plus 16 times of r by n divided by 4 times of r by n plus of 3 is going to be simply, and your r is basically 1 to n, so this is going to be simply of the form of integral 0 to 1 9 plus 16x divided by 4x plus of 3 dx, right? Now how we will solve for this question? Which is simply a question of definite integral. So it is a simple question of integral, so we are going to split this part, and we can take this as 16x plus of 12 minus of 3 whole divided by 4x plus 3 dx, right? And that is going to simply become, now this is going to become 4 minus 3 by 4x plus 3, and then integrating from 0 to 1 dx. And if you just integrate it and if you put it, it is going to be 4x minus 3 times of natural log of 4x plus 3 divided by 4. So then if you put the limit, the upper limit and lower limit, your answer is going to be 4 minus 3 by 4 natural log of 7 upon 3, and that is going to be the value of that particular limit of n tending to infinity for that given function f of n. Okay, so the limit n tending towards infinity from that given function, we basically try to answer this. Okay, so I hope this is clear to all of you. Hello, hello. Okay, hello Solanki. Okay, all right, so you want some guidance. Okay, don't worry, if you are attempting 43 questions and only for sure 3 questions, so what should I do in April attempt? Please help, sir. Sir, I'm giving my 200% in the preparation, but I'm not getting any output. What should I do? Sorry to disturb, but can you answer my question? Okay. Yeah, Solanki, see, the things are simple. Okay, please don't try to overcomplicate things. Okay, I can understand that your effort. Okay, I can understand that you are trying to give your best. You are trying to understand everything into this, right? But first and foremost thing, try to have a patience. Okay, it is not like that you will be able to solve all the questions, all the difficult problem in one day. Okay, if you look at all the successful persons out there in the world, they were not even built up in one day, right? It is all about a matter of patience. Okay, now please tell me, what is the condition? Like, have you completed the syllabus or not? Yes, Solanki, have you completed the syllabus? Can you please tell me on that? Have you completed the syllabus or not? What is the progress on the syllabus? Okay, so with this you will have the answer as 4 minus, so 4 minus 4, 3 by 4. Okay, 3 by 4 times of natural log of 7 by 3, and that is going to be option number B as the correct answer. Okay, I hope this is clear. All right, sir, little bit. See, first and foremost thing. Okay, see, Solanki, first and foremost thing, in order to solve, I understand that you are giving a 200%, but to be honest and to be very clear, in order to solve or do the best out in the exam, first and foremost thing is to basically complete the syllabus. What I would suggest is that this particular time, if you are willing to like try to focus more on the high priority topics, especially for maths, what I can suggest is that, so especially for maths, what I would suggest is that please focus on the calculus part. Okay, now you will be telling me that calculus is a difficult portion, and if your basics are not that very clear, and if your class 11th part is not that clear, then calculus will be a difficult part. Also, if your trigonometry also need to be cleared for discussing the calculus portion. Now I can understand if this particular part is not that clear, then the calculus will be difficult. But to be very honest, the calculus is a very high weightage topic. Okay, what you can do is that, what I would suggest at this particular point of time is that try to go through the like the you can pick up any standard textbook on the JEE mains. Try to go through all the important solved examples. Okay, try to go through the important solved examples, and once you're done with that, and along with that, you have to also study the NCERT. NCERT will hardly take you 30 to 35 minutes for each and every chapter. Okay, so that you can do easily. And what I would suggest is that from any standard textbook like Cengage or Aryan, I'm not promoting anything, but I'm telling you, okay, those are the good books. Okay, so you can follow those books and you can try to solve the solved examples. I know many of the solved example you won't be able to get it, but what I would suggest is that please try to at least stay with the problem, try to get it or try to solve it by your way. Okay, once you understand the basic concept and once you understood the solved example, I would say directly jump to solve the previous year question. Okay, now in the previous year question, please try to analyze a particular pattern. In the previous year question, you will definitely find a pattern that is basically predominant in every chapters. Okay, so try to identify that pattern and try to work on that pattern. Okay, then, and also very important is that whatever you are studying, please try to make a short note. Please try to make a short note. What you can do, you can take a A4 sheet paper, white page, and please make all the important concepts, all the important formulas in a one particular short note. And those particular formula, you can also try to watch of any of these one shot lectures. Okay, or you can study from the book. Okay, but you have to basically make short notes. That is very important. Short notes, solved examples, and previous year question. That can make your preparation little bit strong, right? The next important high priority topic is that after calculus is basically I will discuss and tell you to study is the vectors and 3D. Now vectors and 3D, if you study vectors and 3D, you need to also understand matrix and determinant. Okay, and to be honest, matrix and determinant part is also very easy. Okay, so I would also recommend you to please study matrix and determinant. Okay, so matrix and determinant you can also have to study. Okay, these are the most high priority or high scoring topics. Okay, and along with that, you can also try to add your permutation, combination, and probability part. But I know that permutation combination will require lot of basics and conceptual understanding. So for the time being, you can leave that. And initially, you can start that chapters of algebra. Initially, you can start the chapters of algebra like quadratic equations, okay, like sequence and series, like binomial theorem. Those particular part you can take up. Okay, those are very simple. They will hardly take you 1 or 2 days to complete, right? And along with that, I would recommend all you to basically study the coordinate geometry. Okay. Now, coordinate geometry is very similar that once you understand one particular chapter, you're going to use the same concept in the upcoming chapter. Okay. So that's why I will recommend, please make sure that you complete the coordinate geometry. Coordinate geometry will hardly take you 4 to 5 days. But once you understand the basics and once you try to solve the previous year question, your concepts are going to be very simple. And the questions are going to definitely going to happen. And you're going to basically solve the questions and you're definitely going to gain confidence. Okay. So that is what my advice will be at this particular point of time, right? So at least try to spend a time on studying the calculus part, then you move to the vectors in 3D. But if you look at the easy topics, I would say that please start from here. Please start from vectors in 3D and matrix indeterminate. Start from here. Okay, these are the very easy. It will hardly take you 2-3 days, and with the previous year question, you can definitely do that. Okay, and I have already completed the previous year questions discussion on matrix indeterminate, which you can also find it from the channel. Okay, so please go to the channel and you will find up all that particular content. Okay, is this clear, Solanki? Is this part clear? Okay, so let's proceed with the question then. Okay, Solanki, is this clear? Alright, and if you want any personal doubt clearance or any solutions of your doubts, you can definitely contact the undersigned number in the description box. Okay, so from the description box, you will find the number. Through that number, you can contact me and my team. And if you want any personal doubt clearance and solutions, you will definitely get everything from here. Okay. And please, Solanki, what I would also suggest is that if you are having time, try to watch these sessions. Okay. If you think that if you are having some time, please try to watch the sessions live. Okay, at least what I am solving, you try to see the solutions and try to do the same thing, and also try to copy the same solutions. Okay, so that whenever you get this types of questions coming up in the exam, you can apply the same thing and at least you can get the answer. At least you can, that way you can at least get a +4, and that +4 will definitely help you reach your desired rank. Okay. Okay, thank you, Solanki. That's good. Okay. I hope you understood this. So I will be very helpful to, like, I will be very happy to see you get your desired rank. Okay. And please don't panic. Please, I'm telling that please don't panic. Okay. Have some patience. Things will be tough, but this time will also pass away. Okay. But don't think that this time will pass away with anything you will do it. That don't give up like that. Okay. Give your 100%, and I know you can do it. Okay. Don't let anybody say you that you cannot do it. Show or prove them that you can definitely do it. Okay. And if you are having any questions, any doubt, you can definitely put that in the comment section. You can join the Telegram channel as well, and you can ask me questions. Okay. In that through, we can also connect in a personal chats also. Okay. I hope this is clear. So with this, let's start solving on this question. Please try to focus on this question. Okay. Now, whatever question I'm trying to show you are very important for your upcoming JEE mains examination. That's why I'm trying to show these questions. Okay. So whenever you have this type of question, please try to follow the steps exactly as I'm doing. And if you're following the steps exactly as I'm doing, you're definitely going or bound to get the correct answer. And with this, you're going to get the +4. All right. So let's move to the next problem. The next problem is again a very interesting problem. So let us try to see. It's a question of functional equation, right? So let's try to understand what this question talking about, right? So if we look at this question, it is said that there is a function which is going from all real number to all real number. The domain and the codomain are given, and it is said that is a twice differentiable function. It is a twice differentiable function. Okay, it is given as twice differentiable function such that the second derivative of x is greater than 0. The second derivative of x is greater than 0. Now, this particular word has lot of implications in it. If I am telling you the second derivative of x is greater than 0, that basically means the first derivative function is basically a increasing function. Is an increasing function, right? Is an increasing function, right? So what does basically first derivative basically means? It basically means the slope. So slope is increasing as we are increasing the x. So that basically gives you that this kind of function is a concave up. Okay, so it is basically concave up. Okay, so if we try to roughly draw this graph of the function, we will get this graph as some concave up. Okay, but this is going to be decreasing, so I will try to draw it in terms of increasing. Okay, but the question is, we don't know the increasing decreasing nature. We know that the first derivative is increasing, that means we know the slope of the function is increasing. We don't know that the first derivative is greater than 0 or not. So it's kind of function like, we will have a function which is basically concave up. Okay, something like this, right? Now, so that basically gives you that at each interval, if you try to draw the slope of the tangent, it is basically increasing. That's what the basic concept of the question is, right? Now, once you understand this, it is said that the function of value at half is equals to half, and the function of value at 1 is equals to 1, right? So we have certain questions. So from this, we have to basically predict what is the first derivative of f at x equals to 1. For this, I am going to simply use the concept called as Lagrange's mean value theorem. Okay, so I am going to use the concept of LMVT or Lagrange's mean value theorem, which says that if our function is continuous and differentiable, if f of x is continuous on the closed interval a to b and f of x is differentiable on open interval a to b, then there lies a point C which is basically in between a and b, for which I will have the first derivative of C to be equal to f of b minus f of a divided by b minus a. That is going to be the condition of the Lagrange's mean value theorem. So it is basically telling that the slope of the tangent at x equal to C, which is the interior point inside the region a and b, will be equal to the slope of the chord joining the end point of the curves. Slope of the chord joining the end point of the curves. With this particular statement, if we try to apply it over here for the second derivative, so what is said that the second derivative of any point C is always positive, and I can write this as f dash of b minus f dash of a, right, divided by b minus a. So in this case, your b and a, let us take it as half and 1. Okay, so let us take it at within the interval half to 1. This particular function is continuous and differentiable. So if we try to apply it over here, we're basically going to get f double dash of x is equals to f dash of 1 minus f dash of half divided by half, and for x basically belongs to in between half and 1, right? So from here, this particular thing is going to be greater than 0, right? Now let us take an arbitrary interval inside this particular region. Let us take, so okay, so from here your f dash of 1 minus f dash of half is going to be greater than 0. So what you understand is that your f dash of 1 is greater than f dash of half, which I already told you that f dash is an increasing function, right? Now for this particular case, if f dash is an increasing function, so what I can say that your f dash, now if I take a condition on f dash of x, and I can write it again as f of 1 minus of f of half divided by half over here, right? Now for this case, your x is again between half to 1. Right? Now if you look at this case, this f of 1 is going to be 1, and f of half is going to be half, right? So this is going to be equal to 1. This particular ratio is going to be equal to 1. So from here, what you are getting that for all values of x in between 1 and half to 1, we are basically getting the first derivative as equals to a constant value that is basically coming out as 1. Right? Now this is basically should be just a second. It should be like this. It should not be directly equal to 1. It should be, you are not basically going to comment on the equality, rather you have to comment on the inequality. That is, it should be greater than 1. Now how it is greater than 1, I will explain. So what is the concept is try to understand over here. The concept is that f dash is an increasing function. Now by LMVT, if you apply this concept, that is for any value of x in between half and 1, you are getting that particular value is equal to 1, right? By LMVT, if we do, we are basically getting it directly equal to 1. So what does it basically mean? This basically means that f dash is a constant function. Now, if f dash is a constant function, then f double dash will be equal to 0. So then how can I tell that f double dash of x is greater than 0? So therefore, there is a catch over here. There is a catch over here, right? That's why it's a question of JEE advance. Okay, this is what you have to understand, right? So now on the end point, what you will understand that this particular condition, that is f double dash of x is greater than 0, will only hold true when your value of f dash of 1. Now here in this case, if you put this value of x equals to 1, your value is going to be greater than 1. It will only hold true when your f dash of 1 is greater than 1. Okay, I hope this particular part is clear and I was able to make these things clear to all of you. Okay, so with this you will have option number B is going to be the correct answer for this particular problem. So the simple thing what you understood is that, so f dash is increasing for some value of x in between half and 1, and from that Lagrange's mean value theorem you got that f dash of x in between half and 1 is directly equal to 1. So that means that in between half and 1 your function is basically a constant function, right? But when you're putting exactly at 1 or greater than, or exactly 1 or greater than 1, that particular first derivative is coming out greater than 1. I hope this is clear. Okay, I hope this particular part is clear. Alright, please let me know this part is clear or not. Very good, Solanki. That's good. Please let me know this part is clear or not. Okay, I hope I was able to make this question clear to all of you. Okay. So these kinds of question can also come up for your JEE mains as well. All right. So with this, let's move to the next problem. And this is a very interesting JEE mains problem. Okay. This problem was basically from JEE advanced question, but this kind of problem has been repeated in your JEE mains, right? So how to solve this question? Let us try to understand, right? The question is going to be very simple. What are you going to do? First of all, let us try to evaluate this expression. That is limit x tending towards infinity. It is going to be x squared plus of 1 x plus 1 divided by x plus 1 minus, so I'm going to take this total minus ax into x plus 1 minus of b into x plus 1, and that is basically mentioned as 4, right? So what we are going to do over here, I'm going to take the limit, that is x tending towards infinity, and then I'm going to club the terms of x square, that is going to be 1 minus a plus x times of 1 minus a minus b plus 1 minus of b, and then whole divided by x plus 1. Now the question is very interesting in the sense that in order to get these questions of infinity by infinity form to be a finite value, your highest power of the polynomial in the numerator should be equal to the highest power of the polynomial in the denominator. So if you look at the highest power of the polynomial in the denominator, it is basically 1, whereas the highest power of the polynomial in the numerator, it is basically equal to 2. So therefore, in order to this limit to exist, in order to this finite value to exist, this 1 minus a should be equal to 1. So from here, you get the value of a is equal to 1. So from here, you get the value of a is equal to 1. Now once this value is becoming 0, so then it is a very simple question of limit. The limiting value is going to be simply by taking x common from the numerator and denominator, and that's how you get to the value of 1 minus a minus b is equal to 4. And from here, you can put the value of a, and you will get b is basically equal to, minus of 4. You are basically going to get b is basically equal to minus of 4. So once you understand how to solve the infinity by infinity form of limit, because this is basically the form of infinity by infinity form of limit, right? And in infinity by infinity form of limit, I will only get a finite answer. Whenever the highest power of the highest degree of the polynomial in the numerator and the denominator is the same. I hope this is clear. So with this manipulation, we are going to simply get to the results directly by evaluating these results. Okay. So once we get to the value of a, and then we solve for the b in order to get for the value of the b, right? So from there we get the values of a and b. So with this, option number b is going to be the correct answer for this particular problem. I hope this is clear to all of you. All right. Please let me know this part is clear or not. Is this clear? Okay, so now what I'm going to do is that I'm going to leave some questions as a homework problem. Okay, now this is a very interesting homework problem that I would like to I would request all of you to please try to go through it. Okay, now let me repeat about the differentiability condition. The differentiability condition is nothing but the continuity of first derivative of x. Okay, So differentiability condition is basically that your RHD should be equal to LHD, right? So what is this condition of RHD and LHD? So that is basically, that is limit x tending towards that particular point x of a. So your limit value of f of x minus f of a whole divided by x minus a should exist. Okay, should exist. If this particular thing exists, that is your left hand limit for this case and the right hand limit for this particular function, if it is existing, then I will call that a particular function is differentiable. So, and one more thing, in order to function to be differentiable, that particular function must be continuous. First of all, we have to check for continuity and then we go on to differentiability check. Okay, so for a function to be differentiable, it must be continuous. I hope this part is clear. So I will be looking forward for your answers in the comment section. Okay, so this is a homework problem. Please try to solve this homework problem and let me know the answer you are having in the comment section. Okay, so with this, I will be very happy if you are able to solve these questions by yourself. Okay, so make sure that you try to solve this question. Okay, make sure you try to solve this homework problem. This problem is very simple. I have already repeated the concept that you need to understand. If you just go to the last lecture of limits, I have discussed about continuity, and over here I discussed about the differentiability, right? So with this part, I hope this is clear to all of you. And I have one more problem as a homework problem. Okay, now this is a very simple problem. We are going to use the concept of the limit, the formulas of the exponential limit to get to the answer of this question. So these are the two homework problems that I would like all of you to solve this and let me know the answers in the comment section. Okay, you can always let the answer, and if you want to join me, you can also always connect with me on the Telegram channel. And if you want to get personalized doubt clearance or personalized guidance from me regarding your topics on maths, okay, or chemistry or physics, you can always contact the undersigned number to get connected with my team. All right, so that you can find the number in the description box over here. All right, and you can also join the Telegram channel from the description box. There will be a link of the Telegram channel as well. Right, so with this, let us end our session over here. I hope these two homework problems, I hope you have taken this down. Okay, maybe you can take a screenshot. Maybe you can take a screenshot and try to solve this two homework problem and come up with the solution. Okay. Okay, I hope you have taken a screenshot. So with this, let us end our session over here and